Am I audible to both of you? Okay, so today we are going to discuss the new chapter and it is our circular motion, right? So one thing I want to ask, is it started in your coaching or not, you tell? Okay, okay, okay. So first of all, we will start the of kinematics of circular motion, right? Kinematic of circular motion we will start with, because the first bigger box given in the sheet is of this, right? So in the kinematics of the circular motion, it is very much similar to the translational motion, but in the rotational, right, in the rotating motion, right? Listen, what is the circular motion? Although the circular motion may be defined as if a particle is moving in a circle, right, on the circumference, then the motion is called the circular motion, right? First of all, first definition is angular displacement. Angular displacement. What is the angular displacement? Suppose if this is a particle, it moves from point A to point B. So the angle made by the particle on the center is called the angular displacement. If this is the radius R and R, right? Angle made by angle made by particle on the center, right? This is the angular displacement represented by theta. Are you getting or not? What is the unit? Unit is radian. The SI unit is radian. Are you getting or not? Although the other unit is degree. And what is the relation? 180 degree is equal to pi radian, you have to remember. Is it clear or not? Okay. Second thing is angular velocity. Angular velocity. Angular velocity omega. It is a vector quantity, right? So the angular velocity may be defined of two types. Two types of angular velocity we can define. How it is? First is the average angular velocity. Angular velocity. What is the average angular velocity? Listen one thing. Suppose it is in the same way, the total angular displacement divided by the total time taken by the particle. The average angular velocity is defined as the total angular displacement divided by total time taken. What is the angular displacement? The angular displacement is theta 2 minus theta 1, t2 minus t1. It is delta theta upon delta t, and this is the average angular velocity. Is it clear or not? What is the unit? Unit is radian per second. This is the average angular velocity. Are you getting or not? Sometime it may be treated as the vector quantity, sometime it may be treated as the scalar quantity. For smaller angular displacement, this is treated as the vector quantity. For big angular displacement, it is treated as a scalar quantity, right? This is the average. Average always ask between two time intervals, right? But the next second is instantaneous angular velocity. Angular velocity. What is the instantaneous angular velocity? The instantaneous angular velocity is the velocity at a particular instant. Angular velocity at a particular time interval, time instant, right? That is that, at particular time instant. And mathematically it is defined as delta theta upon delta t become d theta upon dt, right? When it is so, when limit delta t tending to 0, right? And this is defined as the instantaneous angular velocity. So this is the differentiation of the angular position gives the instantaneous angular velocity. That is differentiation of angular position gives the instantaneous angular velocity. Do you understand this? In the vector form, it may be written as d theta upon dt. It is a vector quantity. It is a vector quantity, and direction is given by right hand thumb rule of the angular velocity, also of the angular displacement. How, what is the direction and how does it find, right? How we find this, I will explain. Copy this. Yes, completed both. Yes, very good, very good. Listen, now we check how to find the direction. Okay, so for this angular displacement, take your right hand. The angular displacement itself a vector quantity, right? You have to remember this. you may write. And how to find the direction? Using the right hand thumb rule. If a particle is moving, suppose in this way, on this circle, particle is moving anti-clockwise, so it is axial vector over here. So this is the direction of the angular displacement, right? And you may write after this, right, the angular displacement, if a particle is moving like this direction, you may write like direction. How to find the direction? If a particle is moving in this way, and maybe the particle moving in this way also, right? If it is moving with the help of the right hand direction, the angular velocity and angular displacement in the same direction. And if it is moving like this, right, so this is the direction of the angular velocity. Do you understand this thing or not? We suppose this is of a particle. Instead of this, if there is a disk or fan like you in your room, right, it is the solid body, and if it is rotating like this, so this is the angular velocity of the disk. And if this disk is rotating like this, right, this is the angular velocity like this. If it is rotating like this, the angular velocity is given by this. If it is rotating like this, direction of the angular velocity. Is it clear or not? Please copy this. Very good, very good. Completed? Yes. Now the second thing is the angular acceleration. First, it is very much similar to the kinematic: displacement, velocity and acceleration. In the same way, the angular displacement, angular velocity, and now angular acceleration. Angular acceleration. The angular acceleration is represented by alpha. This is of again two types. First, the average, right? Two types. The first is the average angular velocity, average angular acceleration, right? Alpha average. And second will be the instantaneous angular acceleration. Is it clear? Okay, listen one thing. The average angular velocity is that, suppose if there is a disk or a particle, you can assume, right? That is the thing. So if initial angular velocity of the disk or particle is omega 1, and after some time, right, the angular velocity of the disk or the particle maybe become omega 2 after some time at t1 and t2. So it is defined as, the average angular velocity is defined as ratio of total change in angular velocity, and average angular acceleration is defined as total change in angular velocity divided by total time, right? Total time. So the total time is treated as t1, t2 minus t1 and omega 2 minus omega. Although the average angular velocity or angular velocity itself a vector quantity, so therefore the average angular acceleration is also be as a vector quantity. Is it clear or not? And direction, how the direction is given by, I will explain. This is in radian per SI unit is radian per second square. The dimension formula, if you want to right? This is t2 minus t1. It is a vector quantity and direction is given by a right hand thumb rule. How it is direction come, I will explain. First copy this. Complete it. Complete this and say done, sir. Right, very good, very good. Okay, now I explain the instantaneous angular acceleration, right? What is the instantaneous? Instantaneous angular acceleration, right? Angular acceleration, angular acceleration, alpha t, right? At a particular instant of time, the acceleration, angular acceleration is called the instantaneous angular acceleration, right? Or the rate of change of velocity, angular velocity at a particular instant is called the instantaneous angular acceleration. I'm writing the definition. First I will explain. Listen one thing. Delta omega upon delta t become d omega upon dt, right? Delta t in dt. What is the difference between delta t and dt? I suppose that you understand, but still I will explain. Listen, in the rough you can write what is the delta t mean. The delta t mean t2 minus t1. What does it mean? Suppose the instant of time is 2.0000 second, that is 2 seconds, and after some time the suppose the instant of time is 2.0001 like this, right? So what is the time difference? It is 2.00001 minus 2.00000. So what is the delta t? It is 0.00001 and delta t treated as the minus 6 second, right? So if a particular instant and after very small time interval, 1 microsecond it is, the other time interval is present, then the delta t is very small, and when it is small it become dt. Although this is a part of the differentiation in the mathematics we taught in also in physics, but I am telling you the delta t become, this is called the elemental change, and this is called the change, right? What is the change? Suppose t2 is the 3 second and t1 is 3 second and t2 is 3.5 second. So when delta t is 3.5 minus 3 is equal to 0.5 second. You understand this? So this is called the delta and this is called the del or differentiation. This is called elemental change and this is called the simple change. Are you getting or not? In the average, this time interval will be like 5 second and the 10 second. But instantaneous angular acceleration mean first interval is just right now 2 second, and just after the this time interval the second interval is achieved, right? So the delta t become dt and delta omega may be written as d omega when if limit delta t tending to 0. This is the mathematical way to write this thing you will learn in the mathematics, but I try to explain. So delta omega upon delta t become d omega upon dt when limit delta t tending to 0. This is delta t is equal to 10 to the power minus 6 second it may be written as delta t tending to 0. Not, it is delta t is not 0. It is not like that. It is tending to 0. And therefore, it is defined as the alpha d omega upon dt. In vector form, you may write like this. That is the rate change of angular velocity. Rate of change of angular velocity at a particular instant, right? Rate of change angular velocity is defined as the instantaneous angular acceleration. Is it clear or not? Vector quantity it is as usual, and the SI unit is again the radian per second square. No difference in that. Do you understand this? The meaning of the instantaneous and the average. Average will be asked between the two time interval, right? And instantaneous is asked at a particular time interval, right? Now I will explain it is a vector quantity and how to give the direction. For example, it compare with the translational motion. If velocity is in this direction and the velocity is continuously increasing, so acceleration is in the same direction. But if the velocity is in this direction, right, and it is decreasing, so acceleration is in the opposite direction. Is it clear? In the same way, in the circular motion, or sometime it may be treated as the rotational motion. Suppose if the particle is over there, right, it may be treated as the disk also, and it is moving like this, right, it is rotating like this. For example, the fan in your room. So when it is at rest and you switch on and there therefore it start rotating like this, so the angular velocity is increasing. If it is rotating like this and the angular velocity is in this direction, if angular velocity is increasing, right, therefore the angular acceleration, which is the axial vector, similar to the omega, because it depends upon the omega, in the same direction will be. If omega is increasing, then increasing. What is the direction of alpha? The same as the angular velocity. But suppose if the particle is moving like this, right, so direction of the angular velocity is given by right hand thumb rule, and if it is decreasing, omega is decreasing, right, so what will be the direction of the angular acceleration? Alpha, opposite to the angular velocity. So this is the direction of the alpha. This is the angular velocity and alpha is the opposite to this. Do you understand this? If you want to ask any doubt, please you can ask. Is it everything is clear, Varsha? Very good. So this is the direction of the angular velocity and the angular acceleration. It may be treated as the angular acceleration, it is maybe angular retardation. The calculation wise, it is the similar to the kinematics we have done with the constant acceleration. If alpha is constant, right, mean the magnitude is not changing, then similar to the three equation of motion, we can use the omega is equal to omega naught plus alpha t, right? Theta is equal to omega naught t plus half alpha t square, right? The the omega square is equal to omega naught square plus 2 alpha dot theta, right? Very similar to the translation motion, v is equal to u plus at, right? And the s is equal to ut plus half at square it is, and the v square is equal to u square plus 2a dot s. This is the dot product, right? Similar to the circular motion, translation motion. One more thing, the d theta upon dt, it gives the omega, right? D omega upon dt, that is the differentiation, double differentiation of angular position, is give alpha. Sometime alpha may be written as d omega upon dt into d theta upon d theta. So the d omega upon d theta into, right, d theta upon dt, multiply and divided by this the angular acceleration. So it is d omega upon d theta into omega. Alpha may be written as omega d theta upon dt. I think you know that in the translation motion the acceleration is dv upon dt, and in terms of displacement v dv upon ds. It may be written as like this. So all the equation are very much similar to the translation motion. You may copy this side, only you have to copy this, right? Read this question, and in this question what is given? What is given? The theta is the angular position t cube minus 3t square plus 4t minus 2, right? And they are asking, what they are asking? The average angular acceleration. Whenever they will ask the average angular acceleration, they will give definite the 2 time interval, and on that time interval you have to find the angular velocity. So the angular velocity is, differentiate this, minus 60 plus 4, it is as a function of time t you obtain, right? And at t1, what is t1? t2 minus t1, 4 minus 2, right? This is 4 minus 2. So omega 4 minus omega 2 you have to subtract. So this is 2 second, this is omega 2, 3 2 square minus 6 into 2 plus 4. This is 12 minus 12 plus 4 is equal to 4 radian per second, right? So this is, and at 4 second omega is equal to 4, 3 into 4 square minus 6 into 4 plus 4, it is 4 चौक 16 48 minus 24 plus, and this is 28. Is it clear or not? Radian per second. So therefore the average angular acceleration we can find with the help of this 28 minus 4 upon 2 is equal to 12 radian per second square. This is the way how to find the average angular acceleration. Is it clear? Copy this. Okay, so in this question what is given? Suppose a particle is moving, start moving in a circular motion like this, right? This is the top view. Suppose at t is equal to 0, the particle start from here, right? And then after some time, when it reaches at this point, it start his stopwatch, right? What is the angular acceleration alpha? It is 3 radian per second square. Here it start. Suppose this is the t node, and then at the end of the particle cover at end of the 4th second. So now the 4 second, this is the time instant t plus 4 second. Do you understand or not? That is the thing. The particle cover 120 angular displacement. Do you understand or not? This is the 120 radian. Theta is given, right? Theta is given. Are you getting or not? So they are asking this time interval, right? So the theta is equal to omega t plus half alpha t square I will apply. Do you understand or not? So from 0 to t naught, the theta is supposed to be theta naught, and this is 120. So theta is equal to, initially angular velocity is what? 0. I am writing t is equal to 0 to t naught. I will write theta naught is the angular displacement plus half alpha is what? Alpha is 3 into t naught square. So theta naught is 3 by 2 t naught square. This is the equation number 1. All right. Now the second equation I will make from 0 to t naught plus t by 4, from A to B. A to B. This is the equation. Then A to C. I will apply again. This is the theta is equal to omega naught t plus half alpha t square. Initial velocity 0. The angular displacement is now total angular displacement theta naught plus 120 is equal to half alpha into t naught plus 4, because this is the 4 second. Is it clear or not? That is the thing. So it may be simplify further. Theta naught square plus 16 plus 18, 8, 4, right? This is 8 t naught. This is half 3t naught square, multiply this 3 by 2, right? 3 by 2, 16 plus 8t naught. Are you getting? This is theta naught plus 120. This theta naught and half 1 by 3 t naught square, it will cancel out. So what will we have? 120 is equal to 3 by 2, 16 plus 8 t naught, right? 3 चौक 12, 80, 16, 8 t naught, right? And 80 minus 16 is equal to 8 t naught. 10 minus 2 is equal to t naught. T naught is equal to 8 second, right? So 8 second is the correct answer. So what is the question? I am explaining again. T0 starts. After some time it start his stopwatch, and then for next 4 seconds it sees that it covered the 120 radian, right? So they are asking this time interval at which time he started stopwatch, right? Okay, so circular motion we are going to start here, right? There are two types of the circular motion, the uniform circular and the non-uniform circular motion, right? So first I will discuss the uniform circular motion. Uniform circular motion. Can you tell me something about this? What is the uniform circular motion? UCM. Please tell something about this. Yes, definitely. And other thing, listen. When a particle moves in a circle with constant speed, the motion is called the uniform circular motion. In this case, the speed of the particle remains constant. But since the direction is changing, therefore the velocity vector are not equal. Are you getting or not? The velocity vectors are not equal, although their magnitudes are equal. Are you getting? V1, V2, V3, V4, V5 are equal, but their direction is not same. That is why these four variables, the four velocities are not equal. Do you understand this thing or not? So in the uniform circular motion, in the UCM, speed remains constant, but velocity is what? Is continuously changing. Continuously changing. Do you understand or not? If velocity is changing, there must be some acceleration or not? Yes. What is the acceleration? Rate of change of velocity is called the acceleration. If velocity is changing, therefore there is acceleration in this motion. There is acceleration in this motion. Do you understand or not? And this acceleration is called, centripetal acceleration. It's called centripetal acceleration. Do you understand or not? Which is responsible for changing the direction. Is it clear or not? And its magnitude, its value, its magnitude is given by AC is equal to V square upon R, and direction is always towards the center. Do you understand or not? Listen, one more thing. If a particle is moving in this way, suppose its velocity is v1, so here the centripetal acceleration will be toward the center, and its magnitude will be v1 square upon r. When it reaches to this point, moving with velocity v2, its centripetal acceleration will be this. Are you getting or not? Suppose its magnitude is v. So the AC1 vector का magnitude and AC2 vector magnitude is v square upon r. But again, these two acceleration are not same. AC1 and AC2 are not same. Why? Why they are not same? Please tell. Yes, the direction is not same. That is why their acceleration is not same. Do you understand or not? Copy this. So this is the uniform circular motion basic. The velocity remains changing, keep changing, and when the velocity is changing, the acceleration must be there. How this expression comes, I will explain you, but just right now you can remember this, right? There is a mathematical form, the mathematical derivation how this acceleration comes, but more important than this is the relation between v and angular velocity. Listen one thing, if suppose the particle is moving right in a circular path like this, right? So this is the velocity vector, right? Where is the angular velocity? This is the angular velocity vector. Suppose this is the radius of the circular path is r as well. Are you getting or not? And this is the centripetal acceleration at this time, right? The radius is r. Do you understand or not? So you will see in this case, when it is moving, the velocity vector is perpendicular to the centripetal acceleration. Also, this angular velocity vector may be shifted for your convenience like this, right? This is the angular velocity. So angular velocity is also perpendicular to the centripetal acceleration, and also v and omega both are perpendicular. Do you understand this direction? Sometime they ask the angle, but if you don't know the correct relation, then you may confuse with this. Any doubt you want to ask here in this explanation? Is it clear? Right. Yes, one more thing I want to tell. The relation between vector v and vector omega. Vector v is the angular velocity, vector omega is the angular velocity. Yes, first copy this, then I will explain. Right. Okay, so now listen how to find the relation between V and R, right? The relation between V and R, you can continue with this. Suppose initially the particle is over here, right? It reaches to this point, right? And after some time, it is moving with the constant speed, and it subtend an angle delta theta in the delta S. The displacement is delta S, right? Displacement is delta S, you can write. The radius is r, so angle is equal to arc upon radius, so delta S is equal to r delta theta. If you differentiate, divided by delta t both side, so this is delta t. And I told you in the mathematics, if you take the limit, right? Limit is a chapter in the mathematics, right? Limit and function. So limit delta t tending to 0, if you take limit delta theta upon delta t. So when limit delta t tending to 0, delta theta become d theta upon dt, and it is omega instantaneous. It will become ds upon dt. So it become velocity. So v is equal to r omega. It is the relation between v and omega, the magnitude only, right? But in the vector form, the v is equal to omega cross r, right? Sometimes they give the velocities. R is what? Say the r is the radius vector, v is the velocity, and this is the angular velocity. Are you getting or not? If this is a circle, suppose the angular velocity is in this direction, this is the velocity vector, and this is the radius vector. Radius vector of particle p with respect to the origin. So V comes to be omega cross R. Listen one thing. How does it come? Suppose this is R vector, you can substitute, you can extend this is the omega vector. So omega cross R is equal to V. Are you understanding the direction? Omega cross R is equal to V. Listen. This is the R vector. The vector in the space can be shifted like this. So I have shifted this vector R, and this is the omega, right? So omega cross R is equal to V. So therefore, the correct relation, although it is the magnitude, most of the cases this will be used, but in some important question, it will be used, right? This is the one way to write the centripetal acceleration. AC is equal to V square upon R. You can write from here, and the V is equal to R omega can be written. So R omega upon R whole square it is. So centripetal acceleration may be written as R omega square. Is it clear or not? V square upon R. So the centripetal acceleration may be written as like this. Listen one thing. Copy this fast. Any doubt you want to ask so far? Any conceptual problem if you want to ask, you may. Very good, very good. Listen one thing. Okay, listen one thing. If there is a centripetal acceleration in the circular motion, when a particle is moving, there will be the centripetal acceleration if this is the speed v of the particle, right? So tell me, if there is a acceleration in the motion, so there must be some force or not, by which this acceleration is produced, and that force is called the centripetal force, right? The force which produce the centripetal acceleration, the centripetal acceleration is called centripetal force, right? And what is the centripetal force? We can apply F is equal to ma. So if I write this vector, the centripetal force direction should be in the same way. So Fc must be equal to m into AC. And what is the centripetal? If we write the magnitude m into AC, so what is the AC? Say V square upon R, or it may be written as Fc is equal to mr omega square, right? It is a vector quantity. And what is the direction of the centripetal force? Its direction is always towards center. Do you understand or not? Towards center, right? Acceleration is there must be, without force the acceleration, how the acceleration can be produced, right? So that is the thing. So the responsible force for producing the centripetal acceleration is the centripetal force, and this is the magnitude. Copy this. So this is the centripetal force. Listen, one very important point is that this centripetal force is not a new type of force. This centripetal force is not a new type of force, right? Rather, how many types of force are present in nature? There are 4 types of the forces. What are those? Electromagnetic, gravitation, and weak nuclear force, strong nuclear force. This force is not a new type of force. Rather, it is obtained by some other forces present in nature, right? Present in nature. It is not a new force, right? It is obtained by it, or you may say it is the resultant of some other force present acting on the particle, right? Sometime it is, for example, like friction, like tension in the string, sometime the gravitational force, sometime electrostatic force, gravitational, electrostatics. In the class 12th we will discuss the magnetostatic force, right? So these are the forces, sometime normal reaction, right? These force provide the centripetal force, right, when the particle is moving in a circular motion. This is the very important point, or very important point, which the student and the teacher also don't understand this thing, right? Few teacher only, but there may be the confusion. So when I will explain the with the illustration, you will understand the importance of this statement, right? Copy this. You have to resolve the force, resolve the forces, resolve the forces acting on the particle, acting on particle, performing circular motion in the direction of the radius, in the direction of radius and perpendicular to it, perpendicular to it, perpendicular to radius. That is the thing. Just copy this. I will. So for some examples we are going to discuss on the basis of the uniform circular motion. For example, first, suppose there is a string right over here, and this is the block of mass m. Are you getting or not? Suppose there is a table. You may assume this is the table, right? Like this. There is a small hole, and the string is passes through this, and it is moving. This is the mass m. It is moving in a circular path like this. The string tension is over here. It is moving like this. Are you getting or not? Right? The angular velocity is what? Omega. Angular velocity is, or you can say it is moving in this circular path with speed v, like this. The radius r. Can you find the tension in the string? Find tension in the string, right? String. It is performing uniform circular motion. There is a hole, right, and this is the table. This string goes in the frictionless hole like this, and you are holding this string over here. The tension will be over there. Are you getting or not? I will ask you. Tell me, how many forces are acting upon this? There is a frictionless table, mu is 0. Tell me, any of one of you, how many forces are acting? Hello? Tell me, how many forces are acting upon this mass? Right. This is the mg, normal, right? And other forces? Listen, I told you in this statement that centripetal force is not a new type force. Okay, you tell me it is acting by, say, gravity, earth, right? And this is normal reaction by table. This is the electromagnetic force by table. Who is exerting the centripetal force? No one? No. That is not the thing. Listen, mg, normal, and tension in the string when it is moving, right? It is moving in a circular path. So tension is always towards the center. This is the tension. This tension is the force which is acting toward the center, is responsible for providing the centripetal force in this case. Do you understand? And this tension is by string only. Nothing centripetal force is there. And now the second point I told you, you have to resolve the forces along the radius and perpendicular to the radius. If this is the side view, if you see the top view, right, the tension is in this way and it is moving like this, right? The normal is upward direction and mg is downward direction. You understand the figure? So what is the net force toward the center? Net force towards center will provide required, I'm writing complete, will provide required centripetal force. Centripetal force. Do you understand or not? So therefore, and what is the centripetal force? If the velocity is v, mass is m, what is the value of the centripetal force? Say mv square upon r. Are you getting or not? So therefore, the tension is equal to mv square upon r over here. Are you getting? So in this string, what is the tension? Say mv square upon r. This is the very simple example of the UCM, uniform circular motion, right? Copy this example. This is the example number 2. Okay, now suppose there is a horizontal table. Now we have tied the two masses. This is the 1 kg and this is the 2 kg, right? And this is placed in the horizontal table like this, right? And this is the side view and this is the center. Suppose this is the 1 meter distance and this is another 1 meter distance, or suppose this is the 2 meter distance, and these two balls are rotating. This is the string 1, this is the string 2. Do you understand? And these are rotating with the common angular velocity like this. One end is connected to the another ball. So they are moving like this. They are moving like this. Are you getting or not? Right. So from O to A and to B. O to A is the another string. The tension is T1 in this string. Understood? Right. And the another string is T2. So you have to find the tension T1 and T2 in the string. If you want to see the top view, this is the one mass, this is the another mass, right? And on the horizontal table, they are rotating like this. This is the angular velocity. This is the 1 kg block, this is the 2 kg block, the string is T1 and T2. Do you understand or not? This distance is 1 meter, length of this string, the length is 2 meter. Is it clear or not? For example, this is the one point and the another point is tied behind this. They are rotating in the same circle like this, After some time, they are over here. Are you getting the question or not? There will be the two string and the two tension in the string. The angular velocity I am giving, it is the 10 radian per second. Now you have to find the tension T1 and T2, right? Yes. So just tell me how many forces are acting upon these two blocks. I am writing the solution this side, right? You may do in that only. There are two balls which are placed on this and they are rotating with angular velocity omega like this. So how many forces are acting upon this? The 1g, the normal, N1, 2g and normal like this. On this case, the tension is always away. The tension is T1 and T2. First of all, keep in mind that no centripetal forces they are acting upon this. Only the forces present in the nature, electromagnetic, gravitational, normal reaction, friction, electrostatic force will act upon the particle, not the centripetal force. Rather, you have to calculate the force acting towards the center that will provide the required centripetal force. So in this particle, the T1 is acting or not, you tell me. The T2, what is the direction of T1? Tell me. Very good. Tension is always away from the mass, and T2 is in this direction and T2 is in this direction. If you are confused with the direction of the T1, T2, I can explain this once again. Please tell me. Direction of tension acting on the particle. Clear? If not, then I can explain it. Clear? For 1 kg. For 1 kg. 1 kg. What is the net force towards center? Net force towards center. Can you tell? This is the center. Tell me. T1 minus T2 is equal to centripetal force. Will provide required centripetal force. So T1 minus T2 is equal to what? Mr omega square in this case. Mr1 omega square. Is it clear or not? T1 minus T2 is equal to m, 1 kg. Radius of this circle is what? Say 1 meter, omega is tan square. Is it clear? This is the one equation, right? For 2 kg, the non-2 and 2g will cancel out. What is the net force toward the center? Yes, net force towards center will provide required centripetal force, and this is only the T2 which will provide m2 r2 square omega square. The angular velocity will be the same. The m is 2. The radius of this circle, can you tell me what will be the radius of this circle? Tell. 3 meters. Yes, that tan square. It is 300 duni 600 Newton. So the T2 is 600 Newton, and therefore T1 minus T2 is equal to 100 is equal to 600. So T1 is equal to 700 Newton is the correct answer. Is it clear or not? So the next topic, you can say the time period of the conical pendulum. Conical pendulum. First we are discussing all the uniform cases of the uniform circular motion. Listen, do you know the simple pendulum? This is the simple pendulum. The length is L, the mass is m. When you give the little angular displacement, what will happen? It will, right, oscillate about this. Is it clear or not? It will oscillate in the same plane. What is the time period? 2 pi root L upon G. Although we will discuss in the SHM, right? But I think you have gone through this once till now. Time period of the simple pendulum is 2 pi root L upon G. You will remember like this, right? But what is the conical pendulum? Suppose there is a support and the string is over there of the length L. You take it side. In this case, you just leave and it oscillates. You take a side by theta and you give some horizontal velocity, right? So it will move in the horizontal circle. Do you understand or not? This pendulum is called the conical pendulum, and for this conical pendulum you have to find the time period of oscillation. Is it clear or not? This is the conical pendulum. It is moving like this. Do you understand the question or not? You tell me. The length is theta and we can assume the radius is r, right? First copy this, then I will explain further. We are going to find time period of oscillation of this conical pendulum, right? You may draw on that case. So you tell me when it is moving like this. This is the center, this is the length, this is the theta. It is moving continuously like this. How many forces will act upon this at this point? Can you tell? Yes. Tell me how many? Mg and tension. Any centripetal force? No. No. And one more thing. So the second point I told you that you have to resolve all the forces. This is the center of the circle. This is the radius. You have to resolve the force along the radius and perpendicular to the radius. So this is T. Mg is perpendicular to radius. There is no need to resolve this. And this is T. It need to resolve because it is not in the direction of this or not this. So this is the T cos theta and this is the T sin theta, right? Some student always confuse that if this is Mg and it is theta, so this is Mg cos theta and this is Mg sin theta. No, Mg sin theta. So you need not to resolve this. Only tension is not acting in the proper direction. So you need to resolve the tension. So you tell me now, what is the net force toward the center? Net force, yes, towards center will provide required centripetal force. Centripetal force. So T sin theta is equal to mv square upon r. Do you understand this thing or not? And listen one thing. If you consider this particle in the vertical direction, right? This is in x direction. You can assume this is the x and this is y. This is in x direction. And in y direction, can you tell me what is the relation between T cos theta and mg? It is not going up, no, it going down. The net force in the y direction is 0. Therefore, T cos theta will be equal to mg. Equation number 1 and equation number 2. Any doubt if you want to ask, you can. Please. 1 divided by 2, T sin theta, T cos theta is equal to what? Mv square upon mg. Tan theta is equal to v square upon rg. Although this is the relation, right, which is used many times, right, but we have to find the time period of oscillation or revolution. So the time period will be total distance divided by speed. Is it clear or not? From here, yes, rg tan theta, and the speed may be written as this. So 2 pi r upon root rg tan theta, and this is equal to 2 pi root r upon g tan theta. It is right. This is the time period, 2 pi. This is r upon g tan theta. Listen, one more thing. We don't know the radius. We know the length of the circle. So what is the sine theta here? The sine theta in this triangle, perpendicular upon hypotenuse. So L sine theta it is. Do you understand? So this is L sine theta upon G. Tan theta may be written as sine upon cos. It will cancel out. So T is equal to 2 pi root L cos theta upon G. In most of the book, the expression for conical pendulum for time period is given this, but it may be further modified, right? It may be simplified like this. Suppose this is the point of suspension in the center of circle. The height is h, the length is L, this is theta, this is radius, right? So you tell me what is the cos theta. In this case, h upon L. So therefore T is equal to 2 pi root L h upon L, right? Or you may write h upon L, h is equal to L cos theta. So T may be written as, this L cos theta is what? Say h upon G. Are you getting or not? Now it becomes simple. It is very much similar to the simple time period, simple pendulum. T is equal to 2 pi L upon G. Where what is h? Where what is h? Is the depth of the height of the point of suspension from center of the circle. Height of point of suspension from center of circle, right? So now it become easy to understand or to remember, although this is formula also given in many books, but you sometime they give directly h, so you may remember this. Is it clear? Any doubt in any step if you want to ask? Very good. And this is the case we are discussing first, the uniform circular motion. Uniform mean the particle is continuously moving without changing its speed. Do you understand or not? So few cases are left, right? For example, the circular motion on the horizontal track, and there are few example you can say, or the concept you can say. So in the next class we will discuss this. Please copy this.